All right, guys, here is question number 3 from chapter 9. I actually put a little formula in here already. It'll make our lives easier in a minute, but I'll show you where I found it. It says, suppose a university advertises that its class average size is 31 or less. A student organization is concerned that budget cuts have led to increased class sizes and would like to test this claim. A random sample of 42 classes was selected. The average class size was found to be 32.8 students. Assume the standard deviation for class size at the college is 7 students using an alpha of 0.01. Okay, so there's all our stuff, okay? So I always try to start with just like trying to know all the variables that I have, okay? So, so it says the amount in number, or the amount that we're assuming things are, I'm going to call that X, is 31. So that's the average, that's what we're testing, I guess, is to see if it changed from 31. All right, so we did a sample of 42 classes. So N, our sample size is 42. And the average class size, X bar, which would be our sample mean, right, was 32.8. And then it tells us our population standard deviation is 7. And that's important, right? Because if it was a sample standard deviation, that might change things. But this is a population standard deviation. It just says the standard deviation for class size at the college is 7 students. And then again, and then our alpha is 0.01. All right. So that's all of the information it gives us. So the first thing it wants us to do is determine the null and alternative hypothesis. And so all we're testing here is whether or not class size has gone up, right? Because that's what they want to know. So our null hypothesis is going to be that it hasn't changed. Okay, so we're going to say that it is less than or equal to this claim number here of 31. And then the testing hypothesis, or the alternative hypothesis, is that it is greater than 31. So this tells us that what we're testing for here, it's a one-tailed test, right? We're testing to see if it's gone up, okay, if the mean has gone up. So the next thing we have to do is calculate our ZTest statistic. And so this is the formula I put over here. They call it Z of X bar, okay? The ZTest statistic we can calculate with this information we have, okay? So all we're doing is we're creating this formula right here, which looks a little scary, but we're creating it here in Excel. So I'm going to say the numerator of this equation is X bar, which is our sample mean, minus what I call X. They're calling it the assumed number. So that's probably actually a better term for it. We're saying the population mean of the null hypothesis, I guess, is what this little thing would mean here. Okay, so it's the sample mean minus the test figure that what we're looking for, which was 31 or less. Okay, and then we divide that by the population standard deviation divided by the square root of little n. And that gives us our Z-test statistic. It wants 2 decimal places, sometimes so that I don't make mistakes. Just let Excel do that for me, 1.67. Then it wants our critical Z-score. So our critical Z-score is just the Z-score of our alpha, okay? So I'm going to use norm.s.dist. norm.s.inv inverse. I'm going to put in the probability. If I do this, it's going to return a negative, okay? So I want the absolute value of norm.s.inverse for the alpha. So there's our critical Z-score, also wants 2 decimal places. All right, so our test statistic is 1.67 standard deviations above the mean, okay? So that means when we measured 32.8, we would expect it was to be above what we, if we thought the average class size was 31 before, and now it's higher, we would expect that to be, the Z-score would be positive, meaning that that average we found was above the previous average, okay? The question is it far enough above that we can assume that, class sizes have gone up on average? And so our critical Z-score kind of represents that point related to our alpha of 0.01, at which we can say definitively that we believe that the population mean has gone up, okay? And so in order for it to be a definitive, we'd say we need a 2.33. So the fact that our Z-test statistic is less than that means our Z-test statistic isn't far enough above the mean that we can feel real confident in saying that the whole population mean has gone up. It could just be the fact that this sample is a little higher, and if we took another sample, it might be a little lower. So the way we compare this always is if the Z-test statistic is less than the critical Z-score, then we are going to accept this null hypothesis that it's the same as it was before, okay, less than or equal to 31. If the test statistic is greater than the critical Z-score, then we're going to say reject the null hypothesis and accept the alternative hypothesis. It looks like it really has gone up. So because the Z-test statistic is less than the critical value, we will not reject. We don't really accept a null hypothesis. That's a good point. We just don't reject it, okay? It means we don't have enough evidence to reject it. And there we go. So I hope that was helpful to you. And I hope you have a great day.